we are going to do something called real-time processing. Okay, so first I'll tell you how this real-time processing is going to be useful, right? So
Last
today we
week,
will, yeah,
sorry, sir. Last
yes,
week
sir.
you didn't, did you take the class for weekdays?
Uh,
Sunday.
I mean Sunday.
no, I was having in the
Okay.
same
I
place.
was,
Ah,
okay, okay. Means did you
oh,
covered
yeah,
any other
that's what I was
topics? I
wondering.
didn't know.
Maybe since you guys didn't join, I thought you guys would be busy there. So
Okay, I
I
thought
didn't
Deepa
see.
joined.
Okay, okay, okay. No, no, no. The Deepa also didn't join. Maybe I'm
I'll
not
drop
sure if
the
it's
videos.
that link confusion or something. I'm not sure.
Okay,
Okay,
continuous.
Yeah.
okay, fine. So till here, I believe we have completed till last week, right? So we
Yes,
have
sir.
completed about how to do the grouping and how to make use of pandas. This is also going to be an additional extension, but is going to be slightly more advanced, right? Because now we are going to be in a problem solving mode where we might have to look into the data, do some processing and all. So this will also be, there is, I'm not sure if you guys have heard about this Apache Kafka or Amazon Kinesis. Apache Kafka, have you heard, Sashi? Heard about Apache?
I heard, but I didn't know about anything.
Okay.
Yeah, something
Kafka,
for data streaming, I heard, sir.
yeah.
Non-stop
Yes.
data flow.
Yes. So it is going to be a very similar concept here, but we are not going to use any Apache Kafka or Amazon Kinesis services here. Instead, this will be a very similar architecture to that. What the concept that we are going to see now will be. What happens is, you know about our ticket booking apps, either our IRCTC, which is one of the most used app in terms of real-time ticket booking, right? Because of our India's population, that is the most widely used app and also more stable, it seems. It has been ranked as number one API or application for doing our real-time booking in the whole world. The reason for that is because it is able to manage so many users at a single point of time. It has been so efficiently designed also. So we all don't know about this. I was also reading about this somewhere and got to know like IRCTC is the number one app it seems for in the whole world in terms of doing these real-time processing. So, because the amount of load that these systems handle is a
Yes.
humongous data system by itself. The reason for this kind of systems, because during that some point of time, you know, you might know about the stuccal booking, the normal booking and all hours. So there will be so many people will be trying to access the systems. So the application should be enough capability it should be having in order to handle so many streaming data which is coming out from, right? So that's the reason why this is ranked as number one in terms of real-time processing. Even not the other things what is currently there because they don't get experience this much amount of users inflow there at a single point of time because of our India's population itself. This is considered as something exceptional. So what happens there? Every time there will be a request which will be sent, and there will be some waiting happening, and there will be a ticket booking happening, and then finally you get the ticket. So in a similar manner, here what we will be doing is, I'm going to try and particularly replicate a real-time scenario for you. So here what we'll be seeing is whenever a new data is going to come, it generally comes in a seconds, right? So for that purpose, I'm going to import a library called time. So from this particular time and data frame or this particular library, I'm going to import a particular function from this. So which will help me to generate a real-time data mostly in a seconds interval. So for that purpose, I'm going to import this particular library. And the next one will be random. So what is the purpose of random? Okay.
So
Yeah, Sashi.
generally, to fill some forms or anything, if we use random, every time it
Mm-hmm.
changes the input.
Hmm. Basically for generating random
Random
integers,
data.
random numbers, and these purpose we generally use this random library.
Mm.
Okay, so the next one that we are going to use is from sklearn. This will be our first machine learning library that we are going to use in our class. So till now we have not seen any machine learning use cases yet, but this will be one of the library which is called as KNN imputer. Okay, I'll have to give you some background about what this KNN imputer is all about. This is called K nearest neighbor algorithm. Okay, this algorithm is called K nearest neighbors algorithm. Basically, what this algorithm does is, so when you are going to replace a value based on a mean, so how do we replace? We take the entire set of values and we divide it by the number of observations, right? So that's how we generally replace a larger number of records. So either we take the mean, or we take the median, or we replace it with the mode, right? So in a very similar manner, here we are going to make use of something called KNN imputer. Okay, so KNN is part of which library or a schema? It is part of our scikit-learn. sklearn we call them, scikit-learn. This is the library that we generally use for machine learning related operations. Okay, so here what are we going to do is, we'll be first importing this data from there is a within that sklearn, there is a module called impute. There is a module called impute, and what this module is going to do is, we are going to impute missing values. But how are we going to impute the missing values? Not just by mean or median or mode. We are going to impute the missing values using this particular algorithm, KNN imputer. Okay. So first I'll tell you how this KNN imputer works. So let's take the number of records. So here assume like I have a set of numbers. So I'm having some numbers here like 1, 3, 5, 7, and I have a missing value. Okay, and I have 10, 12, 15, and I'm having some more numbers also after this. Okay, I'm having 16, 20, 22, and again here some more missing value I'm having, and here I have numbers like 24, 40, 45, 50, so on and so forth. Okay, so if you are normally going to impute the missing values, how will you impute it? You will be taking all these values, you will be
Calculate
taking, so
difference,
yeah,
right? How close it is to the next number.
yeah. So we generally, what we do is we take a sum of everything divided by the number of count, and then we say like it is going to be, we'll sort it and put it in a proper order. Okay. So what this KNN imputer is going to do is, I need to supply a parameter for this KNN imputer. Okay. So I'll need to say, take only nearest 5 numbers to this missing values. If I'm telling, it is just going to take these numbers only, 1, 2, 3, 4, and one more number, 10. So until 10 only it will be taking, right? And it will take the sum of these numbers alone with 10 plus 7 plus 5 plus 3 plus 1 divided by the numbers, divided by 5. So whatever is the value that is coming, it will replace it with that particular mean of these 5 numbers only. So what does this mean? 17, 20, 25, 26 divided by 5, which will be 5.1, I'm assuming. Okay.
If it is
And
not serial, sir,
it is not serial. It doesn't, it just takes the neighbors as it is, right? So it just looks for a neighboring values. How is this particular value in accordance to my neighbors? and it imputes that particular value with the mean of these 5 values.
Means it
And
will,
here what happens? Yeah.
if it is randomly assigned, if it is start with 50 and then 2, then 45, then again 4, like this, if it is random numbers, if it is not starting with ascending, then how it will perform also?
No, we might have to do a ascending order of this, and then we might have to impute this. So first we might have to sort this particular number in an ascending order or a descending order, and then we'll have to replace or impute this, because the neighbors of that numbers are going to be same as it is, right? So in case if it is not sorted, then we might have to sort it and then do. Yeah.
Then sorted, it all null values will go down or up?
Yes, that's a very good question, Sashi.
Uh,
I think so. Here, KNN imputer. Let me also check on this. KNN imputer. Maybe I think it will sort by default or not. I'm not sure. So maybe my assumption is we might have to do the sorting. Yeah, so I'm just checking on this 1 minute.
yeah.
So they are saying when utilizing k nearest neighbors, sorting variables by number of missing values can improve the imputation process. This is a common practice used across, particularly in environments like R and Python. That's what RA is saying. So basically, we have to reorder the columns and then calculate the number of missing values from lowest to highest. So what happens is, see, missing values will not go to bottom session, right?
Uh-huh.
See, for example, whenever it is there, it is going to sort my nearest neighbors only, right? So for example, if this value is there as a NA, so what happens is this particular null value, whatever it will be replacing. So if I'm saying, see, that's why there are parameters that you need to supply for this KNN. So here, for example, in a KNN imputer, if you are going to supply as 5, it is just going to take these 5 values only, and then it is going to basically do the sorting for these 5 values only. So if I'm going to say for 10 values, then it is going to sort for those 10 values only, from the highest to the lowest order. So basically here, the
Basket
sorting
of
option is, yeah.
basket of orders mean.
Yes, the basket of this. Yes, exactly. So that's how this is going to work. So here, based on what I'm going to give as a parameter, how many neighbors I wanted to consider. If I'm going to say, okay, is this option as 100, it is going to take my 100 observations. And for these 100 observations, it is going to sort from shortest to the lowest to the highest value. And then it is going to compute the mean.
Sir,
Right?
when you say
So,
5, when you say neighbor, so it will take left and right. 5 values from left,
Yes,
I mean,
nearest
total.
values, nearest 5. So left and right, nearest to 5. So for example, if this value is the fifth value, it will be taking 4 values from here and fifth value from the next
Oh, okay.
one. Or
Not
it
2
will
values
do
from left
two
and 3
values
from right
here,
side.
3 from right. Yeah, that values might slightly differ. But
Okay.
why it is taking the nearest neighbors itself is because this will be more helpful when we are going to determine some missing values. Not always the missing values will be equivalent to a mean, or it will be equivalent to a mode or a median also in most of the cases. In median, what we do, we also do the sorting, right? In a very similar manner, this does for this as well. But only thing here it applies is it applies the algorithm on the reorder data after we say the number of neighbors that needs to be considered. That is how this is going to work. Okay, so this is one of the machine learning algorithms that works. So basically, it is as a part of our scikit-learn library. So basically, whenever there is NA is there, that will be treated as the missing values here. Okay. So for each of the missing values, this particular algorithm will find its nearest neighbors in the data set. And then it will try to determine based on the distance, right? So it will not be just computing as just like that, right? So for example, if this is the distance between this particular value and the approximate value, basically calculate something called Euclidean distances. Okay, so it computes the Euclidean distance. So to represent this in a graphical manner, let's take this. Let me remove this one. So basically what it does is it takes all these values, it tries to find the distance. So for example, this is going to be my value, what is missing, right? And there are various data points for this. I'm having one value here. I'm having one value here, 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 and here. Assume these 4 points we are having, right? So what is the value that I need to do is I need to compute this one, right? So it tries to compute the distance between this point to this point, and this one to this one, and this one to this one, right? So it tries to take the distance between each of these points, whatever is there, right? And then it tries to do a comparison of which is the nearest neighbor to this point, right? So for your question also, Sashi, in case of if it is sorted or not sorted, we should be seeing this particular value. Euclidean distance is calculated from the non-missing features of the data points. And for each of the data point which are missing value, it finds this, which is the closest neighbor. So that particular neighbor, when it is sorted, it will be missing as in the same place only. So once it is sorted also, it will be coming in the same place. Or if it is not sorted as well, it tries to find the distance there between that points. And then it tries to compute the final numbers based on that. So first it identifies the neighbors. So after the neighbors are identified, the missing values imputed and aggregation to the corresponding values. So either you are saying if it is mean, it will take a mean, or median, if you say it will take a median, or if you want a weighted average, it does the weighted average. Right? So it's not always mean or median or this. So first it computes the nearest pointers and then it tries to do. Okay. So basically I'll give a real-time example. So assume your age is missing.
Means it will take automatically, we can take mean or median, it will take automatically which
No,
is suitable.
we need to give that. We need to give
Okay,
that. Yeah.
okay.
So we'll be mentioning whether you are going to replace it with a mean or a median or a mode or a weighted average. It depends upon what value you are going to give. So if you are going to specify it as mean, it will take it as mean. Else it is median or it is mode. It totally depends on what value you will be giving.
Okay.
Okay. And this is how this Euclidean distance works. Okay. So this is the theoretical part of this. So Deepa, any questions from your side
No, sir.
for
Gain and how many values we need to give, and also we need to give median value or what value?
yes, exactly. By how you want to replace it, you have to mention this. So
Mention.
this is considered as one of the most powerful way of replacing missing values, right? So whenever we are working with data, usual way is to replace with mean or median or mode, but this is considered as one of the most powerful ways to replace the missing values. Right. So this can also be done for various jobs. So here we will be seeing it. How are we going to do this replacement of missing values for a real-time data? So in a real-time data, how it will be coming is first I'm going to create a real-time data. since we cannot replicate a system like Amazon or any IRCTC or like that, what we will do is we will try to create this process in Python itself. So slightly the coding will be slightly more complex. Don't get worried about the coding in case you are not able to understand. But this is something for your information only, so you can make use of this. So first, what I'm going to do is I'm going to create a function here. Okay, so this will be my function name. So I'm going to define a user defined function. This is called generate data stream. So I need to first generate a data set of data I need to generate. So for which I'm going to make use of two parameters. So these are my default parameters of this particular function. One is number of chunks and the other one is my chunk size. So using these two as my variables, I'm going to generate a real-time data. Okay. So for how I can generate a real-time data, I'm using a for loop here. So I'm in that for loop, I'm basically taking this value and I'm iterating it the number of times what is given here. So it is not it's a default value is 5, but user defined value can also be given for this particular function. So you guys know about this concept already because we have seen about functions. How we are going to write this function also, you know. So these two are default parameters only. So in case the parameter is not supplied, it will be taken as this. Okay, is that clear? So going on, here I'm going to take this number of chunks here. And in this chunk, basically, I'm going to create a dictionary object, key value pair, right? So here I'm going to create a dictionary with timestamp, feature 1, 2, 3, and my target feature. Okay. So this feature 1, 2, 3, basically I'm going to use this random function and I'm performing based on the number of chunks. If it is this, then generate into 100. So 100 into 100 will be generated for feature 1. So 100 into 60 will be generated for feature 2 and 100 into 50 will be generated for feature 3. And I'll be just taking, and this will be my target variable. So can you guys tell me what this particular piece of code will do? This is simple to understand. You know, we are just calling this random function and trying to generate the numbers. What will this line do? Sashi.
Random integer.
Deepa. Yeah. What it is doing, so random integer it is going to generate. So the integer is going to be between what value?
0 and 2, sir? No, right?
The integer will be either 0 and 2 or 0 and less than 2.
Okay.
So which means 0 and 1. What do you think, Sashi? This function, what it will generate?
0 to 2 between.
0 to 2 will
0,
2
oh
be
yeah, I got it. No. 0 or 1. Why? Because 2 is
yeah, the max limit,
max
right?
limit,
So the
right?
upper
So
limit.
0 and 1.
Yes, yes. So
0
it will
and
be
1.
generating between 0 and 1. And this is going to generate the data from based on the chunk size. So that's what I'm going to give it here. So based on the chunk size, it is going to generate 100 numbers. So it will be generating 100 records for 0 or 1. Okay, now let's come to this part, this timestamp. What is this timestamp doing? Sashi or Deepa? Are you guys able to guess what this piece of code is going to do?
Why do you
I
want to put
think
a current
it
timestamp?
will fetch the each millisecond, it will when it is generated, the number, each
Okay,
for
so
loop, each
let's
loop,
decode it part by part, right? So
each loop
first it
by
is
loop.
taking a data frame, it is converting into a date time. Okay, so it is taking the current time and it is taking the seconds, right? So it is, and this part is fine. So it is taking a second part here. So what is this part doing? Time delta. Okay, delta is nothing but usually, as we generally say, it is basically the difference, right? So basically, it will try to avoid the generate the data after every millisecond it will generate. So that's what this is the based on my chunk size. Since I want the data to be generated every second, kind of, and as you know, in any real-time
Any real-time
systems
systems
like Uber or Ola, whenever we are seeing, right? So it will be the data will be coming on a real-time feeds. So this KNN is also used for generally this ride-sharing apps. So whenever who is the nearest driver who is available, so at what distance this particular driver is there, so to whom this particular cab can be assigned, and all these things are being used using this k nearest neighbor algorithm. So most of these ride sharing companies make use of this algorithm only, and they try to point out like where is the cab or where is the person standing, what is who is the nearest driver to that particular request in that location, whom it is there. So it just sends to all these drivers. If you see all these ride sharing companies, how it works, you guys have an idea on how these ride sharing companies work, how the drivers are getting assigned, and why there is a surge pricing. Any idea on this,
Yes,
Sasi?
nearby, we are going
Yeah.
to drop or pick up if they are available at nearby distance based on distance and busyness.
Right. So assume there are 10 drivers available. Okay. But there are 12 requests that has come. Okay. Now, for these 10 drivers, there could be each one individual can be assigned. So it first tries to assign the request for each of these drivers based on first come, first serve priority. Right. So it tries to assign customer number one based on the time when he logged the request. Customer number two when he logged the request. Likewise, it tries to do it on the priority order. So, in case during a busy time, if you have seen, especially in India and all, when we are going to book the Uber or the Zola, used to run for a very, very long time. So, during busy times, you will not receive the request only. You will not be able to initiate the request only. Or when you go into the app and try to look for a driver, at that time the server will be loading for a very long time. You might have seen that. So the maximum timeout for that will be like around 3 minutes or so. So you'll be looking for drivers, looking for drivers. It used to come for a very long time. So what happens there is it goes to the system and it tries to find the nearest driver there. Since all of them are booked already, it comes out. It keeps you in a wait loop. So that wait loops goes on and on and on. So that's how these systems are working currently. So what we are going to do here is we are just going to delay it by a second. So that's what this piece of code is going to do. Using this timestamp.delta, by few microseconds, this is going to delay the request from one request to another request. So we are going to generate 100 size of data, and which will be in a this chunks we will be seeing. There is a specific purpose behind why I have asked this chunk there. So first let's try executing this one. Is this clear for you, Deepa?
Yes, sir.
Please stop me in case if you are not able to get anything in between. So I'll try to re-explain it again. So now this code has been run. So now I'm going to execute this part. Okay. Now you see what has happened. There is a timestamp that is generated. You see today's date and with 4 5 4 5 27. So that is my first request that has come. So you can see from that onwards, there is a timestamp that is getting generated.
This is
So this
yesterday, sir.
feature, uh, yeah, sorry, 11.6, right? Yes, yesterday I think it is the server is in, I don't know
No, sir.
where, maybe.
Click on generate data stream. Run the generate
Okay,
data
okay.
stream.
I'm sorry. Yeah, I think this was yesterday's code. And yeah, I didn't call this machine. Yeah, today is 11.7, right?
Yes.
So current time is 12:41. right? So from 1241 onwards, this started to generate. This is my first request that has given. And then 42, 43, you see, for each request, there is a 1 second delay is there. So that delay is because of this delta only. So basically in this delta, we are basically saying how much of delay that is required, delay in differences you wanted. So I'm saying you make the delay in seconds. So it is delaying by 1 second for each request. And for each of this, it is generating a feature for me, feature 1, 2, 3, 4, like that. And it is also giving a target value for me. Okay, so what do you guys understand now by a feature and a target? Because now we will be slowly moving into problem solving from after 2, 3 classes onwards, right? So now I want to introduce you to a concept of independent variables and dependent variables. So did we cover this independent variable, dependent variable earlier, Sashi, Deepa? Did we talk about that when we are talking about the variables?
I
No,
don't think
sir.
so, sir.
Okay, perfect. So these are, see, for example, if I'm going to do let's take some real-time data itself, right? So I'll go to Kaggle, and you have opened your account in Kaggle, right, Deepa?
Yes, sir.
Okay, great. So let's take some real-time data itself. So from here, um, car sales prediction. Let's take this as our data set. Okay. So here we have a data set, car sales prediction data set is available. So this is that data set. So in this particular data set, if I'm saying what are my independent variables and dependent variables? Okay. You see here the manufacturer name is there. The model of the car is there. The sales in thousands is mentioned. Years in resale value, vehicle type, and all this information is given. Okay. So assume that this is going to be my data set that I'm going to work out with. I need to predict the price of a car. Okay. So I have these information with me. I have the manufacturer, the model, the sales, how much amount it has happened for, when it was the resale was done, for how much the resale had happened, what is the vehicle type, and all these factors I will be giving. And what I need to predict is I need to predict the price of this particular car. Okay. So if at all I need to predict the price of this car, so this final parameter, right? The price in thousands you can see here. Assume I need to predict this price. So I'll be given with all this information like manufacturer, the model, the sales, the year, the vehicle type. And what I need to do is I need to find the predict the price of this car. Okay, so this is basically a algorithm where we are going to, it is basically a linear algorithm, we can also assume this to be, because what we are trying to do is we are going to predict something which is continuous in nature. Okay, so what is continuous? The value cannot be either 0 or 1. The value will be more of a number which is continuous numbers, which can be summed up and try to derive. So whenever you are going to derive a continuous numbers as an output, we generally start with something called linear regression algorithms we use. So we can say that as regression algorithm, right? So here the price that we are going to predict, right? So that will be my target variable. Okay, because I'm going to predict the price of this car. So that will be my target variable. My rest of all the variables that are here, like the manufacturer, the model, the sales, year of sales, the vehicle type, and all this information, these will be my independent variables. Okay, these are my independent variables, and this variable is called my target variable or dependent variable. They call it as either one of the term. Either we can call them as my target or my independent or my dependent variable. Why I'm calling this as dependent? Because this variable is dependent on all these factors. You see, if the car is this and the model is this, and the sales, what the selling price is this much, in the year of resale value it is this much, then the price of this car will be this, right? So this is basically the insurance amount, year resale value or something, what will be the price of that particular car they are giving. So if these satisfy, my price will be this much. Are you getting this independent variable and target variable, Sashi, Deepa?
Dependent target both are same.
Dependent and target both are same. Independent variable and dependent variables.
So independent are the other columns.
Exactly. Independent variables are the other columns. So I can call them as independent variables or my feature variable also. So we interchangeably call either them as an independent variable or feature variable in the data science terms. Right? It could be either one of that. So a target or dependent, that also they use. Right? So similarly, this kind of a naming convention, what we are going to use, maybe differs based on the organization to organization. Most of them, statisticians call them as independent variable, dependent variables, or feature variable, target variable. That is the wide convention that is used for calling these terms interchangeably. That's clear, Sashi, for you?
Yes, sir.
Independent and target.
Yes, sir.
So here I'm doing the same. So I have generated my feature variables. This is feature 1, this is feature 2, this is feature 3, and this is a timestamp variable. And I'm also predicting my target. My target value, as you rightly said, it will be either 0 or 1 only. So how many records it has generated? It has generated around 100 records. 100 rows and 5 columns this has generated. Okay. So we can make use of this random and create some synthetic data like this. So this is called as synthetic data also, right? So we can regenerate some of the synthetic data using this rand function here, random.rand. I hope this part is clear for you guys. Okay. So now let's move on. So now I have created this particular data set. Here, now I need to introduce missing values, right? So till now, I have not introduced any missing values here because my aim of this particular project itself is to make use of my KNN imputer. So first, for which it needs a missing value. So for this missing value, I need to make use of this KNN imputer algorithm and try to replace it based on my K nearest neighbors. So I'll be doing this, right? So how I can do this? So basically for this, I need, so this is the same code, what I did. And I'm going to introduce now missing values to this code. Okay, so here is where I'm going to introduce the missing values. Basically what I'm doing here is I'm going to introduce missing value in two of my features, which will be in feature 1 and feature 2. I'll be introducing missing values. Okay, so my missing value is going to be of what fraction of my data has to be a missing value. So whenever this new data is getting generated itself, I wanted this missing value also to be created. So that's the reason why I'm reusing the same code below. And as you know how this is getting generated, now what happens to this particular values, it is going to introduce some missing values for me. Okay, so how it is going to introduce the missing values? It is basically going to take this particular feature 1 and feature 2, and I have already assigned this particular data inside a data frame called chunk. So I'm making use of the chunk, and LOC is what? LOC is basically a location. So is primary a label base, but maybe used with the Boolean array? This is basically going to store the location of my particular data set. So whenever there are labels that are assigned, so whenever values are present inside, using this location, what we can do is basically we can access that particular variable's ID or a pointer, what we can call it as. So this LOC is used for that purpose. It is nothing but a pointer to that particular memory location. I'm going to take that location. And what I'm going to do is, whenever this sample of 0.1 percentage is there, which means for every 10 percentage of my data, I'm going to introduce a missing value. Okay. For every 10 percentage of my data, I'm going to introduce a missing value. For which columns I'm going to introduce missing values? Deepa, which columns I'm going to introduce the missing values? Or Sashi?
Future 1 and 2.
Yes. For feature 1 and 2, I'm going to introduce the missing values because that is the feature I'm passing on, right? So this column is going to have this index only. And to this particular value, I'm going to introduce a missing value. The fraction is going to be 0.1, which basically says 10 percentage of my data is going to be a missing value here. So 10 percentage of my data is going to have missing values. And I'm going to pass on this index to my location value. So it knows which is in which location. So after this particular location, 10 percentage, it starts introducing my missing value. How am I imputing the missing value? I'm using np.nan. Np is numpy, nan is not a number. So basically not a number is a notation in Python for representing null values. So basically, that's why I'm using something called NAM. Deepa, I hope, not sure if you have got this fully, Deepa. You need me to
Not
explain?
about the fraction, sir.
Yeah, here, this one.
Mm.
Okay, I'll repeat
See,
it.
same like in the top introduce missing values, we are
Hmm,
using random dot rand integer.
yes,
But
yes.
this is
No,
you are doing chunk dot locator.
yeah, yes. See, I have created this data frame, right? So this
Mm.
particular data of these 100 values that you saw, right? This generate data
Mm.
stream, this 100 values, I need to store it in a particular variable. So that variable is what? That is this chunk. So I'm creating a data frame out of this, and I'm storing all these values into this variable chunk.
Mm. Okay.
So for this particular data frame, I'm looping it once again. It's kind of like a accessing the same loop once again. So same data frame again. Into that data frame, after it generates a random, see, because what happens is this the random number is a automatic function, which by default starts generating the numbers. So when it is generating the numbers, I cannot stop this and introduce missing values, right? So what I'm doing is, once it is fully generating all the missing values, I'm storing that into this and I'm accessing this particular chunk here, right? So this
Mm.
particular chunk.loc is what it will tell me is, so it divides this particular, for example, 100 data has been generated here, okay? So it divides the data by 10. So this point one, what it does is it divides the whole data divided by 10 and it takes each and every chunk 10 values, it splits it by. For
Mm.
every 10 value, it started introducing a null value here. So after every 10th record, null has to be
Mm.
introduced. So that is what I'm doing here. Since this is a system defined function, we cannot directly interrupt this and then try to insert and then come back, right? So we have to do that. This is how in real time also happens because I do not want to replicate. I can directly insert it after this is done also. Since we are re-replicating something what is happening in a real time, I'm trying to do that on the go. So that's why we are using this fraction and then this index. So usually for any function, whenever we are going to call, we will be returning that particular value. Some value will be returning. So previously what we did return a particular keyword, return this chunk, so that this is getting displayed here whenever we are calling this function. But here we are not going to use return. Instead, we are going to make use of something called yield. Okay, so this is a new term for you guys. What this yield is going to do, right? So you can understand this yield as something similar to that of return, but it is not same as return. So what this yield is going to do is, it's basically measures only, basically this is a generator. Yield is used in a generator functions. So return a value and it pauses the execution for a while. Okay, so basically I do not want to insert it just like that, because after 10 values I'm inserting, I need to pause this particular random generator. So how am I pausing that? I'm pausing that using this yield function, yield method. Instead of return, I'm using yield and I'm saying sleep for 1 second. So basically here what it does is it tries to generate the data every 100 data, 10 data. Once it is generated, it pauses for a second and it waits, and then it's insert. Why we are waiting for a second? For just this operation to complete. So it should take less than a second only, but just for our purpose of just to not to interrupt the system in between, we are just pausing it for 1 second. So that
Is
is
it
what the sleep.
mandatory?
Sorry, Sashi. No, it is not mandatory, but generally it is a good practice, because you see here we are inserting the records one after the other, right? After 1 second. So
Yeah.
when we are also inserting here also 1 second means it will make sure that there is no interruptions to this code. So everything is happening in a fly here. So that's the reason why we are doing a 1 second gap between one insertion to the other one.
The units of S means SR 5, sir. This is in
Yes,
above
yes. The unit of S, this means seconds. So basically, so
1
that's why
second.
if you see in the output, all
Yeah.
these data points are generated one after the other. You see, this is the seconds, hours,
Yeah.
minutes, second, 16, 17, 18, 19,
18,
20.
19.
You
Okay,
see,
okay.
so all are 6 9
Every
only.
second for each second.
Exactly 1 second it is doing. And
Okay.
similarly, we are making the same loop wait for 1 second and then do this missing value imputation into that.
Okay.
So basically, we are inserting missing values into this chunk.
If I
Okay.
want to make it 2 seconds means unit of 2s or how
No, here
did
what you can do is, so here it is already done
units?
in 1 second only. In delta, I think here there is a parameter pd.np delta. So here
Okay.
we might have to increment it by one more.
Okay.
Uh,
Means we can make it by
yeah, we
customize it.
can. Yes, yes, we
Customize
can
it.
customize it. We can customize it.
Okay.
Yes.
Okay.
Okay. So now, okay. So Deepa, this part, any questions here in this yield and chunk?
No, sir. Suppose if we run only that top one chunk equal to pd dot data frame one,
Huh.
you will still get some missing values
No, I will not get any missing values. Let's see
because you
that.
are
So
inserting
the,
random integer.
right. So in a random integers, let's see how are we supposed to look into the missing value, generate data stream. So here, which is the data that is there? So this is the data stream, right? Let me save it in some variable. Test, generate data stream. Okay, now I'm going to say test dot info. So now I have stored it into a test. So you see here, there are no null records.
Okay.
So in the timestamp feature 1, 2, 3. target, there is no null values at all,
Okay.
right?
So
So
in
it
the
doesn't
next set, you are wantedly introducing the null values for every
exactly
10.
introducing, because we are going to make, we want to make use of this k and an imputer, right? So in a real-time data, so why, how this will be useful, I'll tell you after a while. But this will be helpful for us in real-time data processing. So what happens is, in a system you might be working on, in some systems where the data just got inserted or it is getting inserted on the fly, right? So there could be some scenarios where you have to do the analysis on the fly instead of waiting for or trying to build a particular logic and trying to do things. This is how the data is going to come. So these are the customers who are going to come and buy. I wanted to find that on the fly. For example, this is currently an Amazon Great Indian Sale is coming out, and I know what are all the products the customers are currently buying, right? So I need to know what are the products that most of the customers are buying and what is the recommendation I need to give it to the customers, because I have already done the analysis of my customers, and I know this customer is going to buy a phone, this customer is going to buy a TV, or this customer is looking for a washing machine or some other gadget, right? So I need to target these individuals on the fly, right? So this is something like a real-time data analysis that you are going to do, because you know the pattern of customers. So now on the fly, you wanted to give them a particular suggestion or a target, and you want them to make or buy a particular thing there, right? So in those kind of scenarios, we'll be making use of something called real-time data analysis. So for which we need to do this processing on the fly. So that's what we are going to see now. So we are going to do a correlation analysis, and we are also going to do a missing value treatment here. So for that purpose, we are generating this. Okay, that's clear, Deepa.
Yes, sir.
Okay, so now we are going to make it sleep for a 1 second, and I'm generating this data. Okay, so whatever data that is getting into this generate data, since I store this generate data in a test step, if you see. So I just store this function in test for looking into, right? So similarly, I'm going to loop through all these records, and I'm going to say, I'm going to display that records basically. So I'm saying for chunk in generate data, so take all data from there, which is my data set, which is this all data set. And from there, you take the chunk value and then try to concatenate. So basically what I'm doing here is, so this will get stored under chunk. So my missing value will get stored into chunk. My all data will be present inside this, right? Because here is where I'm saving the data frame. You see here, this chunk data, pd.data frame. So I'm going to concatenate this and this. So what happens is, now my missing values are getting inserted properly. So we saw this function last time, right? This concat is used for what operation? Sashi? Concat
Appending
we
or
use for, yeah.
joining to.
Yes, basically to merge or union both the
Union
data,
operator.
union of two data sets. So that's where we use this concat for. So I'm saying this is my data set 1, this is my data set 2, merge both of them and ignore the index. Why am I giving ignore index? What it does? If I'm saying ignore index equal to false.
It will randomly insert if it is I think so. Randomly insert.
No, it will not randomly insert. What happens is, if we see this example here, last class when we were checking about this ignore index, you see here, it was just getting the index of this should get one after the other, 0,
Yeah, yeah.
1, 2, 3, it has to generate. So when we are inserting from two different data sets, without that, what happened here, you see, 0, 1, 0, 1, it is inserting. Right? So this is not the right way to do the insertion, because
Yes,
it's
yes.
just inserting by axis alone. So we are saying ignore index equal to true. Okay. So here is, that's what I'm doing. I'm ignoring the index and I'm now regenerating this data. Okay, let me generate it once
ಏನಣ್ಣ?
again. This is the data that we will be looking into. Okay, maybe we'll take a 5-minute break after this. So, and then we can come and continue there. So now you see the data set is created and it also has some null values. It is clearly seen here. How many null
Yes.
values we have and all these
Uh,
information will be, we can test it out here. So we can see this particular data. So it is called all data. And this will basically tell me how many nulls we have and what other information. Okay, let's take a 5 or a 10-minute break as you guys wanted. We'll come
yes,
back
sir.
again. Okay.
Okay,
We'll
sir.
catch you again in another 5 or 10 minutes. 10 minutes, let's
Okay, sir.
take. 4:35 we'll come. Okay, Sashi, Deepa, shall we begin? If you guys are back. So now we have created a data set with missing values. This is now having 1000 rows and 5 columns with missing values also. It is having 1000 rows and 5 columns. How many missing values are there? How we can check that in this particular data set?
At the
How to
bottom
check?
it is showing.
Yeah. Where? Where in the bottom?
No, total number of rows you are asking, sir.
No, no, missing values. How to know the missing
Okay,
values?
NAN we are able to see, right?
Yes. No, I need to know in each of the row how many missing values are there.
Mhm.
Each of the columns.
Then for loop we have to repeat
Why we have to repeat for loop?
because it has to check every row and then
Right, exactly. But to display, I don't need to look into the
okay.
for loop, right? So I can directly look in. Info is there. So basically, this is saying here 100 values are missing in feature 1. Feature 2, 60 values are missing because 940 non-null values are there. So, or what we can also do, Sashi, how can we look into the missing values? How to
Data
look for
frame,
missing? Can we
data
look in for
frame,
describe? Yeah,
describe, not describe, sir. This one is null sum.
yeah, this one, right? Is null dot sum, we can say. So describe what it will give. It is just going to tell me what is the values that are there, max value, min value, all
Yes.
this information this is going to give. And if I'm going to use the next one, which is all data dot is null dot sum, this will basically tell me how many missing records are there. So in timestamp, there is no missing values. Feature 1, 100 values are missing. Feature 2, 60 values are missing. Feature 3, there is no missing values, and target is also not having a missing. So now we have found the missing values. Okay. So here is where we are going to make use of our KNN imputer now. Okay. So I have added the
I
nodes.
think
Yeah.
why in future one is 100, why future two is
Yes, that's a
60,
very
sir?
good question. That's a good question. So Sashi, that's because of this. Here I'm taking the chunk, multiplying it into 100,
Okay, okay,
but
okay.
here I'm just saying 50 plus 100.
Multiple
Yeah,
50
yeah.
plus
And
100 into you are multiplying plus 150.
yeah, yes, yes, into 150.
150. Okay, that's why less in the future two.
Yes, yes, that's why there is a
Got it.
lesser records there. Yeah,
Got it.
okay. So here I have given you the notes for your future reference on what each of the line is doing. So what I want you guys to do is before coming to tomorrow's class, I want you to independently try out this code, whatever I have written it here. Try to re-enter this code in your side and try to look in for these additional information in case you might need. So here I have given the comments for each line, what it is doing and how it is working for each line. I have just given the comments here. So please have a look at this and start independently working on this code. because now after this 2-3 classes onwards, it will be individual problem solving. So it depends on how better you are understanding the codes, and this that matters more than anything else. Right? So we are going to do this, and for each line I have given the comments here, what each of the line is doing, just for you to understand.
Okay.
pd.concat, it appends the new data chunk to all data frame, ignoring this equal to true. So each of the line I have given the comments. Mostly you should be able to understand everything. In case, refer to this. Okay. So now we have simulated a real-time data, and we have also inserted the missing values to this. Okay. So now what we'll do is, we know about how many missing values and these things are there in the generate data. And so now what are we going to do? We are going to impute the missing values. Okay. So here I'm going to impute the missing values based on what? I'm going to use this KNN imputer, and I'm going to impute the missing values. Let's understand how we are going to do that. So for imputing this particular missing value, since I want this to be made dynamic, right, I'm creating a function for this. Rather than every time a missing value is coming, I try to take the last 5 numbers and try to take a mean of that numbers and try to impute it. I want this to be more dynamic in nature. So what I'm going to do here is I'm going to introduce a particular function, user-defined function. This function is called impute missing values. So this particular function can be reused for any number of cases, any number of your data sets. So we are also going to make use of this function in our real-time data solving challenges also. So it's like either in our car data set, we wanted to replace the missing values. We'll try to use this KNN imputer. So this will be a dynamic function. Save this function in your drive or in some location where you can easily access this, because this one we are going to reuse it again and again. So I'm creating a function here. So this function, so as you know, generally whenever I need to display a text plus I need to display some values, I can make use of this particular statement in my print statement. So basically F is basically going to tell me that I'm going to create both parameters, which will be both numbers will be displayed, and also I'm going to display text. So I'm within double quotes, I'm saying with /n means basically start of the line, and this /n means end of the line. So that's what I'm saying. So I'm going to say the display before imputation, how many missing values are there? It's basically going to say 160. So that's what this line is going to say. We are just going to say df.isNull.sum. So data frame is where all these inputs will be into. So I need to pass on this data frame to this particular function. So basically I'm going to pass on this generate data to this function. So it takes a data frame as an argument, and I'm going to say how many null values were found before doing the imputation. Okay, so this will be my first step. I hope this line is clear for you both.
Hmm. Okay, sir.
Okay. Next here in this line is where I'm using my KNN imputer. Okay. See here, this imputer is a variable I'm creating. And into this variable, I'm basically calling this KNN imputer. So where is this KNN imputer? This is already taken from my scikit-learn. I have imported this KNN imputer. I'm just calling this KNN imputer. And here you see I'm passing on the number of neighbors I wanted to consider for replacing my missing values. So I'm saying take my 5 neighbors here, 5 closest data points to my missing value, who are my neighbors, and try to impute this particular value based on that neighbors, right? So this will be a useful technique whenever there are missing values in ages or missing values in a particular type of customers or a group of customers within that particular bucket. This will be a very useful technique for replacing the missing values because it will be much more appropriate. So if a salary band is there between 10,000 to 20,000, so I'll be having all the customers sorted based on a particular salary band. So now it is easy for me to replace the values because the values will be between 10,000 and 20,000 only. Maybe it might not be the precise value, but I can at least guess based on my neighbors that I'll be there. Okay, I'll tell you the house price prediction problem also. See, certain group of people would like to live in certain areas. So in India or in US, I'm not sure. In Muscat also, I haven't. I have seen that in Muscat as well. Usually, the local residents of this community who are Omanis, they like to stay in certain areas because they'll be having the land and mostly they'll be staying in individual houses. So the people who are expats or foreigners, they generally like to stay on different areas. For example, here in US, I have heard specific community people live in certain areas and different based on the language. Also, people reside in those areas, right? So here also it is happening. I could see a lot of Malayalam speaking residing in some areas. Tamil in one area, this in Hindi in other area, kind of like they are split across. So they're all staying in a similar communities together. So by then I'll be easily be able to replace the value by considering my neighbors. I can say this particular person, in case his salary band is this, because he's in this group, it should be this much, right? So that's why this nearest neighbors is useful for me. So here I'm going to give 5. So 5 will be my replacing value. So in this line, I'm going to pass this 5 as into my imputer function. And to this function, I'll be taking all the numerical columns. So what are my numerical columns? Feature 1, 2, 3, and target are my numerical features. So only for my numerical features, I want this imputation to work. So because I'm going to replace it with mean, so I do not want to replace for everything. So I'm just taking only the numerical values. So now what I'm doing, I'm just taking a copy of this data which is getting passed here and I'm saying df underscore imputed. So why I'm doing this copy? Anyone, can you tell me why am I doing this copy when doing this imputation?
Making
So
replace in the temp table, like temp table
exactly,
before.
exactly. I'm just since we generally do a backup, right, before doing any operations, any insertions, deletions, and all, in case
Mhm.
something goes wrong, I can revert it back, right?
Yes, yes.
So just for that purpose, I'm just taking a copy of this data frame and then saving it as in df underscore imputed. And to this df underscore imputed for the numerical columns, I'm going to replace this value. So what am I going to replace? So I'm going to replace this fit underscore transform is basically going to take the output of my imputer. So this imputer will be giving me a nearest neighbors. So this particular based on my imputer, whatever results this is giving, I'll be saving that result in here and I'll be fitting that value to all my numerical columns. So here, how many missing values were there? Missing values were there in my feature 1 and 2 only. So here, though all columns are getting passed, I'll be replacing the missing values only for my column 1 and column 2.
Where did you define it, sir?
Sorry, where which define the imputer?
Yeah, because numerical columns, you are sending all feature 1, feature 2, feature 3 target, but we have null values only in feature 1 and feature 2.
Yes, exactly. So what this is going to do is because it knows in where the null values are there, right? So here I need not specifically mention where the null values are there. It looks for each values. So if feature 1 is having null values, it replaces that. If feature 2 is having null values, it takes the nearest neighbors to that, it replaces. Feature 3 is not having null values, so it will not replace. And target also not having null values, it will not replace. So in my real time, why I'm passing all the values, that's a very good question. But in real time, we do not know in which columns null values will be there and will not be there, right? So suddenly there is a data that is coming. I do not know whether this will be having null values or not, right? So since here I have created the data set, I know which column is having a null value. But in real-time processing, we will not know which column has nulls or not null, because we will not have time to sit and analyze the data. So the analysis has to happen on the fly.
So
So
the gap
to
is
make
just 1 minute. In the prior data set, you may have null value in one column. After
yeah,
1 minute, when you get the data, it may have null value in some other column.
yes, exactly. It can. So we do not know this. So to make this process more dynamic, we are passing all the numerical features to this. And it is trying to transform this based on my imputer's output.
You
So
said, yeah,
yeah,
as you
yeah,
said,
Sashi.
um, it will be on continuous values, which is not 0 and 1
Yeah.
immuter.
Which one? Which one, Sashi? The target?
I mean target. Why you taken target?
Okay. So why I
It
have
is 0
taken
and 1,
target?
0 and
It
1
is going to
only,
be
right?
0 and 1 only. Yes, but there could be, see, as of now, it is 0 and 1. My target is. So, just for an example purpose, right? For this example, actually, feature 3 is also not required. Feature target is also not required.
You know, no,
But in a,
it is not a continuous value, right?
yes,
That's what my question. Feature 3 is okay, but why we
yeah.
taken this one?
So there could be missing in target also, right? So what if a target is also missing? So what if a target is not 0 and 1 if it is a continuous target,
Okay, we
right? So
didn't
in
check the
this,
data before
sorry,
it.
we'll not have time to check the data. Yes, yes, you are right. We'll not have time to check the data here because every second new data is going to come. So
Yeah, yeah.
assume my target is as of now 0 and 1, Sashi. So the future target that we will be using is may not be a 0 and 1. It will be a continuous target also. In those
Okay.
scenarios, target can also be null, right? Because target
Yes,
cannot be
yes,
right. To overcome that, I'm introducing here also target. And so just
yes.
for the purpose. But anyway, this fit transform, the main objective of this function is to make these things much more dynamic in nature. So as a programmer, I'll be able to code and keep it running. So tomorrow, any scenarios can happen. I
Yes.
cannot anticipate what will happen tomorrow. So, but I should be future ready for tomorrow's scenario also, right? So to make it dynamic, I have passed on everything, and I'm fitting this transformation to this all the numerical columns which are having null values. It will automatically replace those null values.
Okay.
You are getting it, Sashi, Deepa.
Yes, sir.
Yes, sir.
Okay, perfect. So now let's run this function and see what is the output that this is giving. So now we need to call this function. So I'm going to impute the missing value based on all data. So all data already I have loaded, which is our first data set. So I'm passing on 100 values. So the all values are, I think 1000 values are there in total. So for all these 1000 values before imputation, the missing values in feature 1 is 100, feature 2 is 60, and after imputation, my feature 1, the number of missing values is 0. Feature 2, number of missing values is 0. And this is my values that I'm seeing there in the data set. So whichever value was missing earlier, let's try to figure out which was the value that was missing earlier in the data set. So we can understand. So for example, in row number 3, 20, 25, 11, 7, 12, 25, 54, there was a null value for feature 1. So row number 3, let's look into 12, 25, 07. 12, 25, 07, 50. This one, right? 12, 25, 54. Right? So this was the missing value earlier. So this particular missing value has been replaced by 57. So it has considered 1, 2, 3, 4, and one more value, and it has basically divided it by 5, and it has got a number of 57 for this. So based on the mean of last 5 values, right? So here I can make it even more dynamic. I can say, depending on number of records, I can change this to 10 also, or 20 also, or to 100 also, depending upon my data set and what operation I wanted to perform, right? So now I have made it 10. Let's see now what is the new value that is getting assigned to this row number 3. So this row number 3, earlier it was 57 or something, right? Now this has changed to 56. You see, there is a decrease in the value that is there after I considered 10. Let's make it even more dynamic. Let's take 100 values, missing 100 values, or nearest neighbors of 100. Now let's see how this is changing whenever the missing values are there. So for row number 3, you see now it has become as 47. Right? So depending upon your data set and your requirements, what you have in mind, these values can be altered across. And for different kinds of data, we'll be imputing it with different values altogether. Is this example clear for you, Sashi, Deepa? Any questions that you might have? I hope this is clear for you, Sashi, Deepa.
Yes, yes, sir.
Yes, sir.
Okay. So let's see one more concept. So on a dynamically, you also wanted to see the correlation of these data points. Assume you wanted to understand the correlation of this data. So how do we look for correlation? Did we see correlation as a problem statement? How are we supposed to do correlation? Did we see that as a concept?
For statistical display of that max
Statistical
plot.
correlation. Yes, yes.
Yeah.
Okay, okay.
Hello.
So if you, yeah, yeah, Sashi.
Here.
Yes.
Where did you mention the mean and medians are in the code above?
Okay. So here, yes, that's a good question. So here, this imputer that whenever I'm taking, right? So this particular imputer, I have not mentioned anything as mean or median or this, since it is a numerical value. Since it's a numerical value, and if when I'm not mentioning anything specific here as mean or median or mode, the KNN imputer decides this particular value to be replaced by default.
Means it will take
So it
only
by
mean.
default takes mean.
Yeah,
Yes.
okay.
It by default takes mean as a value, and it tries to replace it by mean itself. Because since it's a numerical columns, we are not considering anything else. So KNN imputer, so that's why this is a machine learning algorithm. So depending upon the data type, what we are using, depending on the data set that we have, so it tries to make this much more dynamic, and it tries to decide on the fly. If it is a numerical values that are missing, and these values are missing because of these many parameters it is missing, so in that case, what will be the most appropriate value? So that will be
Okay.
decided on the fly here. So by
Okay.
default, it replaces this as mean. Right. So nearest neighbors found in training data set, two samples are close to this feature. So, and if in case there are no neighbors at all, that will be a different scenario altogether. So we are not going to see that now. So for now, we'll understand this as whenever the values are missing, it will be replacing it with mean value.
Okay.
Okay, fine. Okay, so now we have imputed this data, and this data has been imputed based on the mean value, based on the number of neighbors that I have given here. As of now, I am just making it as 10 back again and reusing the same. Okay, so now we are done with this imputation techniques and this. So let's also look into correlation. Right? So for the same set of variables, I wanted to perform a correlation analysis on my target. So what is this correlation analysis, and what do you guys understand by correlation, Deepa, Sashi, since we have already revisited this concept in statistics? So what do you
Dependent,
understand by correlation?
dependent on the other variable value changes.
Yeah, if one variable changes, the other
Axis,
variable,
y-axis.
yes, exactly. So the other variable also changes depending on the one feature. So this correlation is done based upon multiple features across. So what we can do is we can try and see this correlation, how it works here. So what is this data set? It is termed as all data, right? Or impute missing values. All data is our data set. So let's take this all data itself and try to perform a correlation analysis here. Okay. So in first, let's see what are all the data points that are there in this all data. All underscore data dot head. So this head is going to give me my top records. So it is having timestamp, feature, 1, 2, 3, target, right? So all these data points are present inside this. So in order to perform my correlation analysis, always have this in mind. Correlation analysis works only for numerical data points. It doesn't work for categorical. Okay. So always correlation works only for numerical data. It doesn't work for categorical data at any point of time. Okay. So what I'm going to do is I'm going to take this missing value all data import and store it inside a variable, and I'm going to take that as my correlation analysis. Analysis. I'm just ANA mentioning it. Impute missing values of all data. I'm going to just store it in that variable. So now I want a clean data. So after imputation and before imputation, I'm just wanting this. So now let me display this core underscore ANA. So core underscore ANA. Okay, so I'm just displaying this data set. So this has all these features and all the records. I have 1,000 rows with no missing values and null values. Okay, question number 1. So how am I supposed to remove the timestamp column alone from this data set? How we can remove this?
You have given it to df dot in the timestamp
Yeah,
unit
so I
settings.
have assigned this to this data core underscore ANA. Okay, so I want to remove my timestamp column because timestamp is something value which gets generated every day. So based on timestamp, I'm not going to say whether it is going to be target 1 or 0. So I want to remove this column. How I can remove this column? Sashi? How this
Pop and
column
remove
can
are only for row values, right? Not to drop the column.
df drop
a df dot drop?
column name
Yeah,
with
okay. So let me create a correlation matrix. So let me create a variable called correlation matrix. So here I need to remove this column. So how I can remove? So I can either use that column name. So core underscore ANA dot, what I need to use?
We have drops, sir?
Yes, we
No,
have
not
drop,
sure.
very much we have drop. Yes. So drop, which column I need to drop? I need to drop my timestamp
timestamp.
column, right? So it is giving me the code CORR. I don't want to use that for now. So I want to drop this timestamp column for now. Okay. So I'm dropping this timestamp column, right? And I wanted to display this value. So now let's see. So what this correlation matrix is having. So this correlation matrix has all these columns, feature 1, 2, 3, 4. And this has all these data points. Okay. So now I need to perform a correlation analysis for this particular data point. So how I can do that correlation analysis? So what I can make use of is there is something called SNS. In Seaborn, we basically have a module called heat map. Okay. So in this heat map, basically what I can do is I can display a correlation matrix. Okay. So that's what I'm going to do here. So I'm going to use sns.heatmap, and inside this sns.heatmap, I'm going to show this particular correlation matrix. Okay. So I'm going to have annotate equal to true, and I am also having some parameters to be displayed here. So there is something called CMap feature. The CMap, what it will do is I can basically give colors in this. So I basically like this color, cool, warm. This color is called as cool, warm. So this color I'm going to use, and whatever parameters that you wanted to pass on, you can basically give those parameters here. So this will be my color that I'll be using for my correlation matrix, and I'll be formatting it. FRMT will be used for FMT will be used for formatting. Sorry, FMT equal to, I can give any format for this. So dot 2f I can mention. So this is nothing but a formatting of that particular text and what font and you need this to be on. So those things you can mention. So this is how you generate a correlation matrix, right? So if you display this, you see this is how a correlation matrix will get displayed there. Okay. You see, this is the first one you can ignore. This is the one what we will be generating. See, but basically what this correlation, before I explain this correlation matrix to you, what do you understand by this matrix? What information are you able to get from this? First, let's understand that.
Field
What
to field,
information are
what
you
is
able to?
means each field to each field, what is the correlation? Which
Yes.
is low or high?
Okay. So we generally ignore this part. This part we ignore. Okay. So what Sashi is saying, between feature 1 and feature 2, what is the correlation? That I'll be able
0.04.
to see it here.
Yes.
Okay. Deepa, what's your understanding?
Feature 1 to target, feature 2 to target, okay.
So I have just created a correlation for everything put together. So
Mm-hmm.
here, in case on my real-time data analysis, I will want to tag all the features and try to see what are all the features which are more relevant to my target and what are the features which are not very much related with my target. I wanted to do this analysis, right? So when I'm going to do this analysis, so how would you interpret this heat maps output?
Maybe as you said, like every, it's like graph
Mm-hmm.
for every variable.
Yeah.
So you are mapping feature 1 with target, feature 3, feature 2, and feature 1 also, not just
Yes.
with other 3 left out.
Yes. Yes. So we are doing how many of these are closely related, which are least related kind of, right? So the darker the color, the better the correlation. So you can, that's why I have used this heat map for that purpose only. You can see the darker the color, so that's why I have given this annotate true will display my correlation numbers, this color and this format for that reason. So when the darker the color, it represents stronger the correlation. So now what we can suggest, so now can you tell me what are all the features which are having more correlation with my target? Which are the features which are having less correlation with my target?